All right, guys. Welcome to Unit 7, Lesson 1, Intro to Exponents. This is a good unit now. There's going to be a lot of work, and you're going to notice that there's no slides for the majority of this. And what we're going to be doing is a lot of work on paper. So you should have this packet that I printed out or gave it to you. And then the homework I'm going to give out to you if I haven't done so already. So anyway, let's get rolling on this and enjoy the day, right? So draw an array to represent 5 by 5. Okay, well, you can draw anything as long as it's 5. I'm going to use X's, right? 5 by 5, and something as simple as that. We're just trying to see how things grow exponentially on this. And when you're looking at it, my 5 by 5x is here. What does this represent here? This would represent 4 by 4. So to figure out how many are in there, you would take 4 and multiply it by 4, right? And you would get 16. So you would. All right. So let's continue on here. The base is the number being multiplied, all right, by itself. An example, all right, Q, and that's, I think, a Q, we'll go with a Q, is the base, all right, is the base. 2 is the exponent, all right. 6 to the 4th power is where 6 is the base. The exponent determines the number of times the base is multiplied by itself. Here's an example, right? 3 to the 5th power is, all right, 5 is the exponent. 2 to the 7th power, 7 is the exponent. Any number raised to the second power is said to be squared. Right? So for example there, so let's just do a couple here. That is read 4 square. That is read 6 square, or 6 to the 2nd power. All right. That is read 10 square, or 10 to the 2nd power. Okay. So just to get an idea, that has 2 specific names. All right, let's continue on. In this case, 3 to the 4th power, this is read 3 is the base, 4 is the exponent. 7 to the 3rd power, and that has a special name, 7 cubed. So a square is 2-dimensional and a cube is 3-dimensional. We have 2 names for both of those. This could be read 9 square, or 9 to the 2nd power. 8 to the 9th power, right? And then finally we end up with 12 to the 0 power. We'll get more into that later down the line. Okay. So just to kind of, base is 5, the exponent's 3, all right? It's 5 to the 3rd power. 19 square, the 19 and the 2. 11's the base and 4's the exponent, so it's 11 to the 4th power. So it is, right? You have your term, 16 to the 4th, 16's the base, 4's the exponent. This would be written as 7 to the 6th power. This would be written as 4 to the 11th power. So really, it's just kind of a review of everything that you've been doing up to this point in 5th grade, probably. And that's generally how it is at the beginning of the lesson, right? Right. Okay, so let's continue on. Expanded form shows the full multiplication of the base. So 6 to the 3rd power in expanded form is written like so. And you're going to notice I use dots now. 3 to the 6th power is 3 times 3 times 3, 3, 3, and 3. 1, 2, 3, 4, 5, 6. There's 6 of them because the exponent is 6. When a number is raised to a power, or when the number is simplified, then it is called standard form. Standard form is essentially the answer. So down here, we're going to kind of work forward, and we're going to work backwards, and we're going to work the middle out. Okay? So Let's get going here. Now, these are all, some of these we might have to work out, others we could do mentally, and I'll help you here. So anyway, this is 5 to the third power. 5 cubed is 125. The square root, if I wanted to use my calculator on that, right, and my calculator, and I'm going to go ahead and clear it, but if I wanted to see, how I can get this into, an exponential form, 36. So what I would do is take this button right here. That's called square root. The square root of 36 is 6. What did that tell me? Well, 6 times 6 is 36, and we can go with 6 squared. It's a nice little function on that calculator, isn't it? 7 times 7 times 7 is 343. All right, that's getting a little bigger, right? Right? And I think that's just 9 to the first power is just a 9, and that equals 9. It's hard to read. I couldn't tell if that was a Q or a 9. 2 to the fourth power is 16. 2 times 2 times 2. 4 cubed is 4 times 4 times 4, and that equals 64. 64 is a unique number. It's a perfect cubed and a perfect square. So think about that. What times what will give you 64? 8 times 8. 3 to the fourth power equals 81. Now, 27. Now look. All right, let's see if we can use this square root working backwards. The square root of 20, it's not a perfect square, so that doesn't help us. So we're going to have to go a little bit of trial and error. 2 times 2 is 4. 4 times 2 is 8. No. 3 times 3 is 9. 9 times 3 is, there it is, 27. So an expanded form is 3 times 3 times 3, and an exponential form is 3 cubed. 2 to the fifth, that's just nice and easy. And 2 to the fifth power, if you didn't know, was 32. 4 to the fourth power, right? 4 to the fourth power is 256. 8 to the first power is just what? It's just 8. Now, this is kind of a unique situation here. They're giving us a couple different numbers to look at here, and we've got to write this. So I'm going to come back here and write this in exponential form. 2 squared times 2, not 2, Mike, times 5 squared times 5 squared. 2 squared times 5 squared. Well, that's 25 times 4 is 100. Let's try that again. 3 to the fourth power times 6 squared. So if I want to use my calculator on this, all right, I'll clear it. 3, we'll use this little arrow button, to the fourth power. Get out of that function and then hit times. 6 to the second power. Get out of that function and hit enter. And we end up with 2916. Standard form, expanded form, exponential form. So that's the first lesson of Unit 7. Hope you enjoyed it. Have a good day.